In the 1960s, at the absolute height of the Cold War, the United States built a missile so powerful, so deadly, that it could never be used without risking the end of humanity itself. This wasn't just another bomb. It was a self-guided, nuclear-powered doomsday machine designed to roam the skies for months, dropping warheads on command. It was called Project Pluto, and its story is one of the most terrifying tales of military engineering ever told. How could a weapon be too dangerous to even test? And what made the brightest minds of a generation decide to build something they knew could lead to global annihilation? Stick around, because we're about to dive into the chilling history of the weapon that was intentionally erased from the history books. A weapon so insane it had to be buried in the desert. The Cold War was a pressure cooker of paranoia and technological ambition. Both the United States and the Soviet Union were locked in a frantic arms race, desperately searching for the ultimate deterrent, a weapon so unstoppable it would guarantee victory or at least mutual destruction. In this climate of fear, the U.S. Air Force came up with a terrifyingly brilliant concept, the Supersonic Low-Altitude Missile, or SLAM. The idea was simple in its objective but monstrous in its execution. They wanted a missile that could fly below enemy radar, travel at supersonic speeds, and stay airborne for weeks, even months, waiting for the order to strike. Unlike traditional ballistic missiles that follow a predictable arc, SLAM was designed to be an unpredictable, relentless hunter. But how do you power something like that? Conventional fuel wouldn't last nearly long enough. The answer was as radical as the concept itself, a nuclear reactor. This is where Project Pluto came in. Its sole purpose was to design and build a nuclear-powered ramjet engine for the SLAM missile. This wasn't just a weapon, it was a flying nuclear reactor, a self-contained catastrophe waiting to be unleashed. The project was handed over to the Lawrence Radiation Laboratory, a place filled with some of the most brilliant physicists and engineers of the era. They were tasked with creating an engine that could withstand extreme temperatures and intense radiation, all while being small enough to fit inside a missile. The challenge was immense, but the stakes of the Cold War drove them forward, pushing the boundaries of what was considered possible, and perhaps what was considered sane. So, how exactly did this flying nightmare work? The core of Project Pluto was its engine, a nuclear-powered ramjet. Here's the simple version. As the missile flew through the air at supersonic speeds, air would be scooped into the front, compressed, and then blasted through the unshielded nuclear reactor core. The reactor would heat the air to an incredible 2,500 degrees Fahrenheit, causing it to expand explosively and shoot out the back, providing immense thrust. Because the reactor could theoretically run for months, the missile had virtually unlimited range. It could be launched from the United States, fly a meandering, unpredictable path across the oceans, and loiter near the Soviet border indefinitely. It was designed to fly just above the treetops, at over Mach 3, 3 times the speed of sound. Its low altitude would make it almost invisible to radar, and its incredible speed would make it nearly impossible to intercept. But the delivery of its payload was only part of its terrifying capability. The SLAM missile was designed to carry up to 16 hydrogen bombs, which it could drop on separate targets as it zigzagged across enemy territory. After dropping its last bomb, the missile wasn't done. It would continue its supersonic flight over populated areas, its powerful shockwave leveling buildings in its path. And then there was the engine itself. Because the nuclear reactor was unshielded to save weight, it would spew a continuous, invisible plume of deadly radioactive fallout. Everything and everyone in its flight path would be exposed to lethal doses of radiation. The missile itself was a weapon of mass destruction, even without its warheads. It was a weapon that killed you just by flying over your head. It was, in essence, a weaponized nuclear meltdown on a guided missile. The sheer danger of this concept meant testing it was a monumental problem. You can't just launch a flying nuclear reactor into the sky. What if it malfunctioned? Where would it land? The team at the Lawrence Radiation Laboratory knew they had to build and test the engine on the ground first. In the vast, isolated Nevada desert, they constructed a massive, heavily fortified test facility, requiring nearly 25 miles of specialized pipe to store the colossal amount of compressed air needed to simulate flight conditions for just a few minutes. The reactor engines were codenamed Tori. In May of 1961, the first engine, Tori IIA, was fired up. For 5 minutes it ran at full power, roaring with the force of 1,000 thunderstorms and glowing cherry red from the intense heat. It was a terrifying success. A few years later, they tested an even more advanced version, Tori IIC. This was the prototype intended for flight. It ran flawlessly, proving the concept was viable. But this success brought the engineers face to face with an unsolvable dilemma. Now that they had a working engine, what next? They couldn't conduct a full flight test. Where would it fly? Over the Pacific? What if it crashed? The environmental contamination would be catastrophic. And where would it land? The missile was designed to fly for months, so landing it safely was never part of the plan. It was meant to be a one-way trip, ending its mission by crashing somewhere in enemy territory, or perhaps in the ocean. The risk of an accident during a test flight over friendly or neutral territory was simply too high. The monster they had created was too dangerous to be let out of its cage, even for a trial run. Ultimately, the very things that made Project Pluto so formidable were the same things that led to its cancellation in 1964. First and foremost was the environmental risk. The idea of flying an unshielded nuclear reactor over any part of the planet was becoming recognized as utterly insane, even by military hardliners. A single accident could render vast swathes of land or ocean uninhabitable for centuries. Then there were the practical problems. Guidance systems in the 1960s were still relatively primitive. The risk of the missile going off course and accidentally irradiating an allied nation, or even turning back towards the United States, was a terrifying possibility. Politically, the weapon was just too extreme. It was seen as a purely offensive, first-strike weapon of indiscriminate destruction. Its use would automatically trigger an all-out nuclear war, with no hope of de-escalation. Even in the midst of the Cold War's madness, Project Pluto was a step too far. It was a weapon that blurred the line between deterrence and planetary suicide. Finally, technology simply moved on. Around the same time, intercontinental ballistic missiles, or ICBMs, were becoming faster, more accurate, and more reliable. ICBMs could deliver a nuclear warhead to a target anywhere in the world in under 30 minutes. While horrifically destructive, they were seen as a cleaner and more predictable alternative to the roaming, fallout-spewing chaos of the Pluto missile. And so, the Pentagon quietly pulled the plug. Project Pluto was deemed redundant and frankly too crazy to continue. But what if it hadn't been canceled? What if, during a moment of extreme crisis, like the Cuban Missile Crisis, a fleet of Pluto missiles had been launched? The scenario is the stuff of nightmares. Imagine dozens of these unstoppable machines streaking across the skies at Mach 3, invisible to radar. There would be no way to stop them. Their flight paths would be erratic, sowing panic and confusion across the globe. As they flew over enemy cities, they wouldn't just be dropping hundreds of megatons of nuclear bombs. Their very presence would be salting the Earth with radiation, condemning millions to a slow, agonizing death. The psychological impact would be as devastating as the physical destruction. It would be a weapon of pure terror, a demonstration that nowhere on Earth was safe. The global fallout would last for weeks, potentially triggering a nuclear winter and the collapse of civilization. Project Pluto wasn't just a weapon to win a war. It was a weapon to end the world. It represented the ultimate expression of mutually assured destruction. A weapon so terrifying that its primary function was to intimidate, to exist as a threat too horrible to contemplate. In a strange way, it was the perfect psychological weapon, one that could cause global panic without even dropping a single bomb. The world would be held hostage by a fleet of flying nuclear reactors, their locations unknown, their intentions terrifyingly clear. In the end, Project Pluto was never launched, not because the technology failed, but because it worked far too well. The engineers and scientists had successfully created a weapon so powerful and so indiscriminate that even the most hawkish military planners of the Cold War had to admit it was unusable. It stands as a chilling monument to an era when humanity, in its quest for ultimate power, came perilously close to engineering its own extinction. The story of Project Pluto is a stark reminder of the fine line between strategic defense and outright madness, a lesson about the dangers of creating weapons that leave no room for error, no chance for de-escalation, and no hope for survival. The Cold War is over, but the ghosts of weapons like Project Pluto still linger, whispering a warning from the pages of history that were meant to be forgotten. Thanks for joining us on this journey into one of history's most terrifying secret projects. If you're fascinated by the hidden stories and erased weapons of the past, make sure to hit that subscribe button and turn on notifications. We have a lot more declassified history coming your way. See you in the next one.